Welcome to today's webinar, Developing Applications with the IoT Button. Our presenter today is Wally Oladen. He is a solutions architect at Amazon Web Services based out of Boston, Massachusetts. He helps customers architect applications for the cloud. Wally has 10+ years experience developing Java applications across different industries, from startups to enterprises, and has helped many customers adopt and architect solutions using the AWS IoT. Wally holds a BA in computer science from Princeton University. Today we will also have Rob Cochran and Richard Elberger, who will be our moderators today answering your questions that you input through the Q&A panel. Wally, welcome. The floor is now yours.
Great. Thank you so much, and hope everyone's having a great day. This session is about developing applications with the IoT button. So what will you learn today? We'll start with an overview of AWS IoT so you can understand all of the services and features and functionality available in the AWS IoT platform. We'll then talk about why the IoT button. What use cases do we see from customers, and how can you start implementing applications using the IoT button? Then we'll get into demos and then use cases for the IoT button. We'll start with an overview of the AWS IoT service. AWS IoT is a managed platform that allows you to connect millions of devices and send billions of messages. The AWS IoT service is made up of several sub-services. If we start on the far left, we have the AWS SDKs that allow you to securely connect your devices to AWS IoT. And we have the AWS registry. Think about this as a device fleet that allows you to connect multiple devices, and then from the registry be able to monitor them, look at things like attributes on devices, and help you keep track of your devices inside of AWS IoT. We then have authentication. This is where you will authenticate your devices and then be able to allow permissions and policies on those devices. So you can allow or deny access, and then let a device publish on a specific topic or subscribe on a topic. We then have the device gateway. This is where you can do one-to-one or one-to-many communication with your IoT devices. So you can set up publish messages, subscribe messages, and let one device or millions of devices subscribe. We then have the device shadow. This is a virtual representation of your IoT device on AWS. You can send commands, and you can also get the reported state of your device. We then have the rules engine. The rules engine allows you to take advantage of all the other AWS services inside of the AWS platform. So you can publish messages to Kinesis, Dynamo, you can publish to the machine learning service, or you can take advantage of our other ecosystems, whether it's pushing messages to QuickSight or doing push notifications using SNS. So this makes all of the individual services inside of AWS IoT. So I mentioned everything from the SDKs to the registry to authentication, device gateway, shadow, and the rules engine. So where would you get started? Many times customers will look at all of these services and say, well, I'm not sure what I should be using, where I should start, and how can I get up and running really quickly? And that's where we had the AWS IoT button. Instead of having an app for that, we created a button for that use case. Because we also realized for these end-to-end solutions, AWS IoT helps take care of the undifferentiated heavy lifting, connecting devices securely, managing and updating devices, helping you visualize your devices. But customers wanted to have a way of taking action on that as quickly as possible. And that's where the AWS IoT button really comes into play. So you don't really have to be a rocket scientist to get things connected. We wanted to help customers focus on their business logic and their business models and their applications, and also invent new ways of really working with their IoT applications inside of the AWS ecosystem. So when we think about connecting all of the dots, we talked about the middle portion heavily, AWS IoT, the IoT cloud platform for connecting your devices and receiving and publishing messages. We also talked about the items on the right. How can you interact with other parts of the AWS system, whether that's S3, Dynamo, SNS, or Kinesis. And what we're focused on a little bit more is what's on the left, the IoT edge and those devices. So for your IoT edge and devices, there are different services and applications you can use. We have services like Greengrass on the far right. This allows you to do local connections with devices. In the middle, we have our starter kits and SDKs, and these are where you would use Python or Java to get software on your devices and then publish and subscribe to different channels. But for this talk, we'll dive into the simple devices, which is our AWS IoT buttons. We have two types of buttons, developer buttons and then also an enterprise program for the AWS IoT button. So I mentioned there are two different types of buttons available today. We have the developer button. You can view this as an experience where you're able to purchase an individual button, connect it to your AWS account, and then publish and subscribe just by simple clicks of a button. You can send a message and then drive some functionality that you're really interested in doing. We also have the enterprise program. And this is where you want to batch create hundreds or thousands of buttons and have those pre-provisioned with things like certificates tied to AWS IoT things, and really able to grow quickly with your button use and have them essentially connected to your accounts right away. So we talked about the AWS IoT button, and it's a great way for developers to really get started provisioning and creating end-to-end solutions using AWS IoT. As far as the process, we have recently released a new AWS IoT button. It now has twice the battery life, so you'll get 2,000 clicks. And you can order it from Amazon, and it's easy to provision just using the AWS IoT button app. And what I'll do in just a minute, I'll actually go in and show a demo of using the AWS IoT button app to provision a set of buttons, just so you can see what the process is for getting started. So let's hop into our first demo, and we'll provision a few buttons using the IoT Button mobile app. So I have my button application. I'm going to launch it. The first time you launch a mobile app, you will have to give your credentials. So this will either be an IAM user or your root credentials for your AWS accounts. And once you log in, you'll be shown this screen. I can drill into the settings in my button app. It'll give me information like which region do I want to provision my button for. It'll also give multiple options from a region selection, but then also some helpful how-tos, how to get started. So for this demo, I'll use North Virginia. And just so you can see some of the details of the screens available, I'm going to click into some of the links on the settings screen. So you can find helpful information here, FAQs, how you can order your button, and developer documentation. So I have one button already pre-configured, but I'll add a few more. If I select the button, I can do things like change my Wi-Fi. So I can go in, select it, and now change my Wi-Fi if I want to. I won't do it for this demo. Or, as I mentioned, you can add new buttons just through this one mobile app. So I'll select adding a new button. What this will do is it will take me through the process of registering the button, getting it on the Wi-Fi, and selecting a LAN function to get started. Once I click the Get Started button, I can either scan a barcode for the box, or I can use my screen, my camera, to scan the serial number. So for this, I'll enter the serial number manually. And what's important to note is as I enter the serial number, what will happen is that part of the serial number will be used for things like creating the thing in the AWS IoT registry, and it'll also do things like using a serial number to tie it to a specific IoT rule. And when we hop in the console, you'll see how the serial number really permeates through all of the things that we automatically generate as part of provisioning the IoT button. So as you see, my name has the last 4 of the serial number. And now what will happen is it's going to create an AWS IoT thing, give it credentials, and now it's going to ask me to connect to my Wi-Fi. So at this point, the screen will go black. I'm going to go through the process of configuring the Wi-Fi network. At this point, you'll connect to your button directly, and then you'll exchange the Wi-Fi credentials that you would like the button to connect to. So now we're back. After my button's on the Wi-Fi, it's going to tell me which Lambda function do I want to trigger for my default IoT button. So you have different options like sending an email, sending a text message, or doing a if then that. So for this demo, I'll do SMS, I'll enter my phone number, and then I'll select this Lambda function. So now this is going through the process of creating an IoT rule and attaching the Lambda function to trigger an SMS message, a text message to my phone. Similar with the first button, I can always select it and drill into other options. I can change my Wi-Fi or change the Lambda function that's associated or delete this button from my AWS account. Now what I'm going to do for our demo, I actually have 3 buttons. So instead of watching me provision a 3rd button, I'm going to go ahead and pre-provision it off screen just so you can see that we can add a 3rd button. And then we'll go ahead and test our buttons to make sure it works. So I'm back in my iOS application. I'll open up the AWS IoT Button mobile app. Just for reference, the middle button is the one that we provision together. So I'll just select it so you know which one that we're going to press. So what I'm going to do now is actually start clicking my button. So I'm going to give a single click and a double click for this demo. And eventually I'll get 2 SMS messages. So that's the first SMS message that's sent to my phone. It goes up, triggers a publish to a rule, and then through Lambda sends an SMS to my phone. And I'll have one other message when I double click. And now let's click into this text message and see what's inside of it. The default Lambda function will have the full serial number available to you. It'll also have a payload that gives the serial number, the battery voltage, and things like the click type. So if you notice, I have the very top of message, a single click, and the very bottom message, a double click. So how does all this work? On the far left, we have the AWS IoT button. And every single time you click the button, it'll send 3 different attributes to you. It'll send a serial number and a full serial number value. It'll send a battery voltage, so how much battery is left on this individual button. It'll also send a click type, and there are 3 types of clicks you can perform with the AWS IoT button. There's a single click, a double click, and then a long press. And a long press is holding the button for more than 1.5 seconds. All of these clicks will go through to, it will invoke a Lambda function. But since now it's an AWS IoT rule, you can do other things like put that JSON document into an S3 bucket. You can push the data into DynamoDB or publish on a Kinesis stream. Let's hop into console quickly and see what was provisioned for us when we created that button through the mobile application. 2 things worth pointing out. The first one is that the IoT button now has a rule that says select star from the serial number topic, IoT button / serial number for my button. What this says is to move all JSON payload as long as it matches to actually fire this IoT rule. And whenever we get a match, it will invoke this Lambda function. As I mentioned earlier, the serial number for the button gets passed through everything else you create. So the rule has a serial number suffix at the end, and then also the select statement and the Lambda function even has a serial number as part of the Lambda function name. This makes it very easy to track which rules and which Lambda functions are associated with your button. Now let's jump into some of the code that was created in that default SMS Lambda function that we created. A few things to point out. We have our payload. This is a JSON version that gets stringified in the very top line. And this event includes everything in that JSON payload on button click: the battery voltage, the serial number, and the click type. In the parameters that sends that SMS message, we have two other attributes of note. The first one is, in the event, we take the serial number out of the payload, and we have IoT button serial number as part of the message. And then we also just pass along the full payload, so we can see all of the JSON attributes that are available for us for building our IoT button applications. So what are some use cases for those three attributes? So we have the click type, we have the battery voltage, and we have the serial number. How can we start thinking about ways to build our IoT applications using the button and all of the logic that's presented to us? So here are some ways of thinking about using click type for your different workflows. You can use a click type to do things like drive priority. On your IoT button, a single click might say that this task is a low priority, while a double click might say this task is a high priority. And you can use a long press as a way to clear priority. So you can use a button to trigger a workflow that says I need to restock inventory, and if I'm running low on inventory, I might do a single press, meaning it's low priority, or if I'm completely out of stock, I might do a double press and it's high priority. And then once inventory is restocked, someone in a store might be able to hit a long press and say that we have inventory back and there's no further action needs to be taken. We can also use a serial number for driving location. You can use a serial number to drive one specific location. So if you place several buttons throughout a facility or throughout a specific area, each button might be tied to a specific shelf or aisle or lane, and that allows you to have one location for one individual button. You can also tie many buttons to one larger area. So a later demo we'll actually use DynamoDB, and it will take every single serial number and it will tie that serial number to a complete store and an area of the store, a retail area. So you can use a database to say these 5 buttons with these serial numbers always relate to the first floor or the second floor or one larger area. You can also use the battery voltage for doing alerts and operations. So you can do things like check for low batteries. Some use cases here is if the battery voltage falls below a specific threshold, you can take a specific action. So you can say I need to reorder another button or provision another button. You can also use a combination of the battery voltage and the total number of clicks to track usage. So you're seeing that certain buttons are used more heavily on a certain area of the floor versus another. Are you seeing people reordering more often from one geographic location versus another? So you can tie battery voltage with your specific usage to make different business decisions. So what we're going to do is build an end-to-end application that's all focused around retail. And for this application, we'll have several store locations. We'll have a primary store location. So this primary store location will sell retail clothing, so jeans, shirts, shoes. It also is connected to other retail locations. So if it needs to look for inventory, it can either look in-house or it can look outside. It can ask another store location, do you have inventory? All of these store locations will have IoT buttons associated with them. For this architecture and a demo that we'll show shortly, we'll use a serial number, and that serial number will be tied to multiple IoT locations, and we'll also use a click type. A single click in this demo will say, look for inventory in the current store. Do I have it in the back office? A double click will say, look for inventory in another location that's close by. All of this goes into AWS IoT. It will trigger a custom rule that we've created that will listen to all button clicks. And then it will trigger a Lambda function that will actually look for inventory and then look to fulfill that inventory. The Lambda function will look at DynamoDB. It'll pass a serial number to Dynamo and say what stock is low. Is it shirts, shoes, or jeans? It'll also pass along the click type to another AWS service. It'll pass the click type to AWS step functions. And if you're not familiar with step functions is a coordination engine that allows you to tie multiple Lambda functions together through a stateful process. So you have a start of your workflow and the end of the workflow. So when this button gets clicked, it passes the click type through Lambda to AWS step functions, and at that point it's going to kick off a complex workflow to find inventory. Which inventory are you looking for? Which article of clothing do you want to restock? And then also, should it look for it in the current store or should it look for it in a remote store? So I'm going to hop into the console now and we'll walk through all of the different components and actually show the button in action. To get a little bit more detail before we dive into the demo, here's what the step functions workflow will look like. That click type gets passed through to fetch available inventory. At that point, we have an inventory choice, so every single button, the serial number, is tied to a certain type of inventory. So our restock shoes or restock shirts. And then the rest of the step functions workflow will try to fulfill the inventory. And all of this is driven by those two attributes in the IoT button and just by a single click or a double click. So let me get into the console. Great. So I have multiple screens up and running. We're in the AWS IoT service now. And what I'll show you is I'll hop into the registry quickly and show you all the buttons that were pre-configured through the mobile app. At the very top, we have 3 buttons that have already been configured for us. So when we went through and provisioned them, it created a thing and a thing type for us. Each button gets its own unique ARN. And with that button provisioning, we give it attributes. Because it's a thing, you can also use the shadow as well. So this button actually creates a thing type, a thing in a registry, and because it's a thing in a registry, you can also make use of the shadow. What I'll do now is I'm going to switch screens and hop into the rules. So by provisioning my button, it created some default rules for me. This is a screenshot you saw earlier. So it has the rule query, and it has the different actions as far as the Lambda functions that are fired. And this just gives you an idea that through this provisioning process, the mobile app is creating a whole ecosystem so your button can just immediately start working. So what will be different when I go through the rule that's created custom is that this actual payload match, the topic match, will be a little bit different. So that has a serial number there. But if I jump into the custom rule that we'll use for this demo, it's going to be modeled slightly differently. So the change that I've made is instead of listening to one specific serial number, I have a wildcard on this topic, this MQTT topic, that says if I click a button, as long as it has any valid serial number, I'm going to invoke my Lambda function. And the reason I do that is because I want to tie the serial number to just one generic Lambda function. Then I'll get the serial number off of the payload. So let me jump into the Lambda function so we can see how that is working. I've created a generic Lambda function name. So instead of having a serial number here, I just have IoT button process. And if I scroll down, what I'm going to do is I'll have the workflow get kicked off, but if anyone does a long press, I'll have it trigger the same SMS functionality that was created when we added the first button in the first demo. In the JSON payload, we're going to take out the click type and the serial number. And these are going to be used as inputs to drive our step functions functionality and for querying DynamoDB to figure out what inventory that we're looking for. So the next step that happens is I'm going to retrieve the location for this button, and this is going to eventually go to DynamoDB. So if we go look at this function inside of the Lambda console, it takes the serial number as input, and then it's going to look for that serial number as a DynamoDB item in the inventory table. And once it receives an object from DynamoDB, it gets an item back. It's going to eventually return that item back to the rest of my workflow so I know which button is tied to what type of inventory. Am I restocking shoes, shirts? Is it from the first store or the second store? So I'm going to switch to DynamoDB so we can look at the items and what's created so we can match buttons to inventory. So what I've done is I've used the serial number in the inventory table. The serial number is going to be my primary key in DynamoDB. That allows me to attach one button to not just one workflow, but a certain product. So is it shoes, jeans, or shirts? In the very last column as well, you'll see that we have a store ID. So which store is this button related to? Now to actually start the full end-to-end workflow, Step Functions requires a workflow ARN. So this is an AWS resource name that says, which workflow do I need to configure? So let's go back into the Lambda function and walk through how this gets processed and kicked off. So this callback function will return the item. And from that point of view, what the item will do is now go through the process of looking for a single or a double press. So the button inventory item takes the item from DynamoDB and looks for the single click or the double click. So single click says look for inventory in the current location. And if I go to the double click, it says check for inventory in the remote location. So as I mentioned, a long click is just going to send an SMS message to me. So just in case I have no more inventory left, what it'll do is it'll say, here's a phone number to send to, just alert there's no more inventory. Now just to dive into what Step Function is going to do is we have two workflows we can trigger. And each one will just say restock inventory workflow. The restock process will take the input from DynamoDB, that workflow ARN that I mentioned earlier of where to go next. And if it's a double click and there's no more inventory in the store, it'll use the remote workflow. And that'll be a different Step Functions ARN that we're going to trigger. For input, what we're also going to do is we're going to exchange the serial number with the type of products you're looking for. So is that button associated with jeans or shirts or shoes? Just to show the last part, we have our state machine ARN. So this is what Step Functions uses to start the workflow for us. And I mentioned the product location. So is this jeans that we need to restock or shoes? We'll take all of this as inputs, and we'll also add some randomization so we can wait for a specific amount of time before inventory is restocked, just to make the example a little bit more lifelike. And all we need to do from this button click to start this end-to-end workflow is just call Step Functions Start Execution. So for one button click, we're going to find where this button is located. We're then going to associate it with a given product in a store. And then we're going to send all of that through the Step Functions and actually start the process of adding more inventory. So what I'll do is hop over to Step Functions, and I'll click into my IoT button demo. So as you can see, there's no workflow that's started. So what I'm going to do is I'm going to take one of the buttons. So these have all been pre-provisioned with clothes, jeans, shirts. And I'm going to press one of the buttons as if I was in the store looking to restock inventory. So as soon as I press the button, it goes up to AWS IoT. We'll trigger the new rule that we've created. We'll then execute this Lambda function. which will then turn around and start a step functions workflow. And all this happens within just a few seconds. So we'll give it some time and refresh. So just from that button click, it's executed one step functions workflow. So let's click into this workflow and see what it does. So from my button click, I've attached this to a shirts inventory in one of the stores. So step functions has started a new execution process for me. And if I scroll down just a little bit, what you'll see is that from this button click, I said, can you fetch available inventory? And this button is attached to shirts. So it actually is executing all these individual Lambda functions. So every single green item is a Lambda function that's checking for inventory or deciding what kind of inventory you're looking for. And eventually it goes to the process inventory and then an end state. As you can see below, all of these functions are being executed just from that individual button click. So I'm able to create this really complex, interesting workflow that ties to my use case, all from clicking an individual IoT button. So what I want to talk about next is, now that we've configured a single button, we've created this workflow where we can take a button, use its click type or the serial number to drive a process end to end. Most customers say, well, how can I do this at scale? What happens if I want to have 1,000 buttons or hundreds of buttons that are distributed across all of these store locations? And we listened to our customers and created the Enterprise program. The Enterprise program is a way for you to bulk order IoT buttons. You can also then brand the IoT button, so you can give it a label. And that label could be tied to your store, or it could be tied to your general retail brand or your customer user brand, just the way that your button is really tied to your use case. What we also do in the Enterprise program is that we pre-provision the security. So in our first demo, we went through the mobile app and we added a certificate, and then we logged into our AWS accounts. With the Enterprise program, we pre-provision all of the security, so your buttons are just ready to be deployed inside of your environment. And these can fit many use cases. Similar to the retail operations demo that I did earlier, you can also have use cases around reorder or click to call. What we've heard and seen from our customers is that these enterprise use cases are really powerful when starting with the AWS IoT button. You can do callbacks for a nurse, you can create maintenance cases, you can even do things like order your favorite pizza or submit a support case. So the capabilities and ideas that customers come up with just give you a lot of flexibility in an end-to-end process around just one click of the IoT button. Just to dive into a customer use case in a little bit more detail, we had MillerCoors speak on stage at our Reinvent Conference about how they leverage the AWS IoT button. And what's interesting about Coors' use case is that they really wanted to try to get closer to their customers and their users. They wanted to say, how can we make it so that if you open your fridge and you need to reorder MillerCoors, that you're able to do so without leaving your home or having to pick up a phone and dial your closest location. So they decided to implement the IoT button as a way to do reordering. So you can click a button and integrate with a partner and essentially have MillerCoors sent directly to your house. An overview of the end-to-end architecture for MillerCoors. They had multiple different touch points for their customers. They started with the AWS IoT button, but also because you're already making use of Lambda and Dynamo and all of these other AWS services that know about your workflows for end-to-end, they also added Alexa and also added an app as well. So now they have multiple touch points with the ability to reorder MillerCoors from a click of a button or asking Alexa. So just to wrap up, I mentioned at the very beginning that these end-to-end solutions are complex. Trying to figure out how to solve this from a business process perspective. You have to connect devices, manage, update devices, visualize data, and AWS IoT helps you take care of the undifferentiated heavy lifting. But many times customers want to figure out how they can take action more quickly. And this is where you can start integrating with the AWS IoT button. And you can build those rich end-to-end workflows just from a single button click. So what's next? How can you go about getting started? We do have a Getting Started with AWS. If you look at our documentation, there is a portion that covers configuring and getting started with the AWS IoT button. We also have our SDKs on GitHub. So if you said, I want to start using a different language or understand how certificates are used on a client, you can also use our SDKs to get started. And we also publish blogs and forums on AWS IoT, so you can find additional information there. Thank you so much. I'll include these links for you so you can always dig into them later. And thank you so much for joining the webinar today.
Thank you, Wally, for the great presentation and engaging with our audience today throughout the presentation. On your screen, you'll see live poll questions. You'll see 3 at the bottom and 1 on top. Please feel free to complete those. Your feedback is very valuable to us, and we do appreciate you filling those out. Now, right now, we have just about 20 minutes here, and in our Q&A session, again, you can still ask questions in the Q&A in the upper left corner. And let's go ahead and turn it over to our moderators for the Q&A portion.
Sure, just to take a few questions. There was one question about the wait time parameter for how long until the next click can be registered. In the demo that we did, there is a wait time parameter. That wait time parameter was just for the back office workflow. So it was a way to allow incremental steps before we actually triggered the next action. There's another question about how you can safeguard against multiple single clicks or multiple double clicks to make sure the user doesn't, say, start 2 workflows at the same time. The benefit with the IoT button and the button being tied to an IoT rule is that by default we connect it to a Lambda function, but you're also able to have that rule, say, go on something like SQS or Kinesis, some service that buffers all of the click events that come through. That allows you to wait a little bit before you actually take the next action. So in our demos, we use Lambda, but if you wanted to wait for someone to, say, do 2 single presses, you could store that in an SQS or some queue or storage and wait for both of them to come through before you start your workflow or your logic.
At this time, I'd like to extend a special thank you to our presenter, Wally, today for his time in the great presentation and demos today. I'd also like to thank our moderators today, Rob, Gijo, and Richard, for answering all the questions in the Q&A panel. If you have any comments on our previous or upcoming webinars or suggestions on topics that you wish AWS to cover in future webinars, please feel free to email us at aws-webcasts@amazon.com. Your feedback will help us improve our webinar programming. I want to thank the audience for joining us today. Have a great rest of the day, and at this time you can disconnect.